In this video, I will be covering the theoretical concepts behind joining tables, why this is done, and how it is used. Let me take an example business scenario. Suppose the management wants to know about the performance of each region so that they can decide on the marketing budget for each region. So they ask you to find the total sales done in each region. There are two things I need for this. First, I need the sales data, which is in the sales table. And second, I need the region, which is part of the customer table. If we could somehow assign region values to each of these transactions, that is, if we could assign that this transaction belongs to the south region and this transaction belongs to the west region, then we can simply aggregate the data on these regions to find the sum of sales for each region. But how do we know the region for this transaction? You must have noticed that there is one field common between these two tables. That is the customer ID column. Using this customer ID, we can match the customer who did this transaction to which region this particular customer belongs. This is the concept of joins. You can join the information present in two or more tables using a common key column or a group of columns. We can also join more than two tables. For example, here we can join sales table and customer table based on customer ID, and we can join sales table and product table based on product ID. Once we have this joint data, we can then find things like how much our customers from the state of California spending on each of the product category. Now let us see what we need to know so that we can create joint data from two tables. First, we need to know the name of the tables that we want to join. For simplicity's sake, let's say we are joining only two tables, so we need to know the name of these two tables. So this is our sales table and this one is our customers table. Next, we need to know the common column based on which we will join these two tables. For example, here the common column was customer ID. Lastly, we need the list of columns that we want from each table in our joint data. Suppose we are trying to find out region-wise sales. We can choose to have all columns from both tables, or we can choose which columns we want from each table. So I can choose only order ID, customer ID, and sales value from the sales table, and region value from the customer table, and then use it to find the region-wise sales. This output will be lighter, but this will have limited functionality only. So which columns should come in the output from which table, this is an option that we have while joining the tables. Now let me tell you about the different types of joins. For the purpose of this example, suppose this is my sales data. I have taken only a few rows and columns so that we can clearly see what is happening. Now we want to join these two tables based on the common key, which is the customer ID. Let us look closely at the customer IDs in these two tables. What do we notice? We see that these customer IDs CG12520, DV13045 and SO20335, these three customer IDs are present in both the tables. This customer ID PG18895, this is present only in the sales table and it is not present in the customer table. and this ID BH11710 is present in customer table but not in the sales table. Now we have four options here which results in four types of joins. The first option is that in the result we get only those results for which customer ID is present in both the tables. So in the first point we have these three customer IDs which are present in both the tables. So in the result we will get only these three customer IDs and all the data from both the tables. So you can see we have order line, order ID, order date, customer ID, product ID and sales value. All of these columns are coming from the sales table, and these three columns, customer name, state and region, this is coming from the customer table. So you can see that the data is joined of the two tables, but the number of rows are less. Only those rows are there for which we have data from both the tables. This type of join is called inner join, and the name is coming from this Venn diagram. This circle represents customer IDs of sales table. This second circle represents the customer ID of customer table. This center shaded part is those customer IDs which are present in both the tables. This is the inner part of the Venn diagram, so we are calling it inner join. Other option is if we decide that in the output we want all the customer IDs from the sales table, they may or may not be present in the customer table. If they are present in the customer table, for example, this first ID CG12520, this is present in the customer table also. If it is there, we will get the customer data. But if that customer ID is not present in the customer table, for example, this ID PG18895, since this is not available in the customer table, we will still have it in the output, and in the places where we are getting the customer data, we will have null value. So you can see the output of left joining. We have sales data for all these IDs because we are getting all the IDs from the sales table. But for that particular ID where we do not have the customer data, the data is null. You can see the Venn diagram for left join. All the customer IDs from sales table are picked, so that is shaded. But those customer IDs which are not part of the sales table, those are left out. So since the left part is shaded, this is called left join. Similar is right join. If we want all customer IDs from customer table, even if no data is available for some IDs in the sales table, we can do a right join. This is the output if we do a right join. We will not have sales data for this particular ID BH11710 because this is not present in the sales table, but this will be part of the output because it is in customer table and we are doing a right join. You can look at the Venn diagram. This time we are taking all customer IDs from customer table and excluding those IDs which are not present in the customer table. Fourth option is if you want to include all customer IDs present in both the tables. In this situation, the result looks like this. We have all the customer IDs. For the customer ID where we do not have customer data, there we get null for customer details. And for that customer ID where we do not have sales data, we get null for the sales transaction details. You can see the Venn diagram. All the parts are shaded. This is why this particular join is called full outer join or full join. Now one question may come to your mind. If we keep sales data on the left and do left join, or if we keep sales table on the right and do right join, will these two give same results? Well, the answer is yes. So even if you have sales table on the left and you do a left join, or you have a sales table on the right and you do a right join, your solution will be the same. I would suggest that you test this out yourself in a Google Data Studio sheet. Now there is one last kind of join left. This is cross join and it is different from any other joins that we have seen earlier. So in a cross join, each row of the first table will be combined with each row of the second table. Now let me explain this with the help of an example. So suppose in my first table, I had these three values of years, year 2022, 2023 and 2024. And in my second table, I had these four quarters, quarter 1, quarter 2, quarter 3 and quarter 4. And what I wanted to achieve was, for each year, I wanted to have these four quarter values. You can see in the resultant table on the right, I want for year 2022, the four quarter values. Then for year 2023, the four quarter values. And then for year 2024. This can be achieved using cross join. So when I do a cross join, the first row of table 1 is picked, that is 2022, and it is combined with each row of the second table, which means quarter 1, quarter 2, quarter 3, quarter 4. Then the second row of year is picked and is combined with the 4 rows of the quarter table. This goes on till the last row of the first table. So as you can see, cross join is very different from any other type of joins, and it has very limited and very special use cases. For most of the scenarios, we will be using the 4 kind of joins that we have discussed earlier. So that is all about joins. I hope you have understood the 5 kind of joins, and now you can select the right kind of join in Google Data Studio while creating blends. That's all in this video. Thank you.